I'm a geologist, and the one thing that we miss out on in looking at climate change is the past. Climates have always changed. Climate changes in the past have been greater and faster than anything we experience in our lifetime.
The first slide sets the stage with a timeline for 4.5 billion years of Earth's history. Over this time, there were 6 major ice ages, an ice age being defined as a time when there is ice at the poles. These are identified by orange-shaded areas on the left-hand side of the timeline. For 85% of Earth's history, there was no ice at the poles. The normal state of the Earth, not an alarmist disaster. We are currently in a Pliocene Quaternary Ice Age, which began a little over 2.5 million years ago.
But the past gives us a wonderful story. In the past, we've had 6 major ice ages. We've had periods of glaciation and interglacials. We are currently in interglacial. We have refrigerated the Earth. But for less than 20% of time, we have had ice on planet Earth. The rest of the time, it's been warmer and wetter. And there's been more carbon dioxide in the atmosphere. And what did life do? It thrived. 6 of the 6 great ice ages were initiated when the carbon dioxide content of the atmosphere was higher than now. In fact, up to 1,000 times higher. So we have from the geological evidence absolutely no evidence that carbon dioxide has driven climate. For some odd reason, the major driver of climate is that great ball of heat in the sky, which we call the sun. You heard it here first. It's really quite unusual.
The next slide shows 600 million years of Earth's history. Atmospheric CO2 is shown as the black curve and Earth's temperature in blue. The first thing that we might notice is that there is no correlation whatsoever. At the left-hand side, 600 million years ago, is the Cambrian period. The interesting thing here is that there was a maximum level of CO2 in the atmosphere at about 7,000 parts per million. This is nearly 20 times the level of the current time period. CO2, moreover, is beneficial to life because during the Cambrian period, there was an extremely high rate of evolution. There was no tipping point, no thermal runaway, the oceans didn't boil away. There was a precipitous depletion of carbon dioxide following that. Why? The answer lies in the fact that about 95% of Earth's carbon in the lithosphere, biosphere, and atmosphere is sequestered in limestone. Limestone is formed from sediments of marine life that were subjected to heat and pressure, converting them to limestone. Life has been consuming and depleting carbon dioxide. This is a one-way path to extinction if not replenished. The carbon dioxide reached a low 300 million years ago, but fortunately CO2 started increasing again, probably due to release from deep in the Earth's mantle by volcanism and deep ocean vents. Today we are at 400 parts per million, a geological low, and in fact also dangerously low. If CO2 were to drop another factor of 2, photosynthesis would begin to shut down, and all life would be well on the path to extinction.
And we change our distance from the sun. Every 100,000 years our orbit changes from elliptical to circular.
This slide shows 400,000 years of data from Vostok ice core data taken from the Antarctic ice sheet. This provides a detailed relationship between carbon dioxide and temperature, cyclic behavior with about 100,000 years of alternating glacial and interglacial periods. Nature has done the experiment for us 4 times with the same results. When CO2 reaches high concentrations, the temperature is dropping, not going up as the alarmist theory would predict. Analysis also shows that CO2 lags temperature by 800 to 1,000 years, and therefore cannot possibly be driving Earth's temperature. There is a plausible reason for the CO2 delay. Warmer water holds less dissolved CO2 than colder water. As the oceans warm, CO2 is released, increasing its concentration in the atmosphere. Milankovitch, a Serbian physicist, suggested in the 1920s that variations in the Earth's orbit and axial tilt caused by Jupiter and Saturn might cause temperature variation cyclically. Variations in the sun's energy output are also likely significant factors. The science is exceptionally complex and definitely not settled. Now expand the timescale for the ellipse at the lower right. Here we can see about 11,000 years of Earth's more recent history as it warmed, emerging from the most recent glacial period. We observe significant temperature fluctuations, also not due to either CO2 or human activity, but other natural causes. Another observation, temperatures have been warmer than today, contrary to alarmist claims. Additionally, Greenland was settled by the Vikings during the medieval warming period, but they were frozen out and perished with the onset of the Little Ice Age.
Every now and then continents start to move, and they move at very rapid rates. They move about this much every year. And at one time a continent can be over a pole, at another time it can be at the equator. Those moving continents change the major heat balance on the Earth, and that's the ocean currents. The oceans carry far more heat than the atmosphere. Every now and then, because of major geological processes, we'll get a great bulge on the ocean floor of new volcanic rock. That changes ocean currents. Every year we have 10,000 cubic kilometres of seawater that goes through new volcanic rocks in the ocean floor. That exchanges heat. The reaction between seawater and the rocks stops the oceans becoming acid. When we run out of rocks, the oceans will become acid, but don't wait up. It will be a long time. We see 1,500 terrestrial volcanoes on planet Earth. We only measure 20 of them, and very few of those measurements are really accurate, but they tell us that a little bit of carbon dioxide leaks out of those volcanoes. But what we don't hear is that there are at least 3.47 million volcanoes on the sea floor which leak out huge amounts of carbon dioxide. We have got pools of liquid carbon dioxide on the sea floor. So, early Earth's carbon dioxide, where did it go? It went into rocks. Where did it come from? It came from rocks. What did it do to the planet? We did not fry and die. We didn't have runaway greenhouse. And sea levels have always changed. Not by the modest couple of millimetres that people are having conniptions about, but we've had in the past sea level changes of only 1,500 metres. That's a sea level change. In Roman times, it was warm. It was considerably warmer than now, and we know that. They kept good records. They grew olives up the Rhine River as far as Bonn. They had wine grapes in Yorkshire. We know from their clothing that it was warm. Possibly they were going to an orgy, but I think it more likely it was warm. And that warming suddenly stopped in 535 AD. And we entered the Dark Ages. And in 535 AD we had Krakatoa fill the atmosphere with aerosols. And it wasn't a big volcano. Only 30 cubic kilometres of aerosols go into the atmosphere. We've had bigger ones in Yellowstone. We've had even bigger ones in New Zealand, where 10,000 cubic kilometres of aerosols have gone into the atmosphere. And we pray for another one, because that's the only way we'll ever beat them at rugby. Just wipe them out. We had two volcanoes, one in Rabaul and one in Krakatoa in Indonesia in 535, 536. We went into the Dark Ages. It was cool. What happened? Crops failed. We starved. We had civil unrest. We had cannibalism. We broke out of that into the medieval warming. First to feel it was the Vikings. The seas became calmer. They could go further fishing. They actually went to Newfoundland, which they called Vinland. In Greenland, grapes and barley were growing. In Greenland, the graves were deep because there was no permafrost. It was a wonderful, benign climate, 5 degrees warmer than now. Eric the Red was saying, come to Greenland, it's a wonderful climate, and it was. And then we went through a period of solar inactivity, and in 23 years, we went from the medieval warming into the Little Ice Age. And that Little Ice Age ended 330 years ago. So what do you think would happen after a Little Ice Age? Do you think it'd get colder, or do you think it'd get warmer? We are in a period of global warming. It has been warming since the Maunder minimum 330 years ago. These were the times when you had the ice fairs on the Thames. These are the times when the Dutch masters painted hoarfrosts and bitterly cold conditions. That was the time when the sun was a bit inactive and we had no sunspot activity. We are creatures of warm climates, and we've been measuring temperature, and we have seen a slight warming from 1860 to 1890, and then a slight cooling until 1910, then a warming until 1940, so much so that the Northwest Passage was open, then a cooling until 1977, and then a warming until the end of the century, and now we're in a period of cooling. This planet has been degassing carbon dioxide since it first formed on that Thursday 4,567 million years ago. Carbon dioxide is a natural gas. It has dominated the atmosphere for an extraordinarily long period of time, and we now are at a dangerously low level. If we halved the amount of carbon dioxide in the atmosphere, we would have no terrestrial plants. Carbon dioxide is plant food. It is not a pollutant. To use words like pollution with carbon dioxide is misleading and deceptive.